In the first question, we have to find the angle between the lines whose DC's direction cosines are given by the equations 2L plus 2M minus N equals 0 and Mn plus Nl plus Lm equals 0. So for that, we have to solve these two equations simultaneously and find the DC's of the lines. From the first equation, we will write value of N, which will be 2L plus 2M, and we will substitute it for N in the second equation. So the second equation becomes M times 2L plus 2M plus L times 2L plus 2M plus Lm equals 0. That will be 2ml plus 2m squared plus 2l squared plus 2ml plus Lm equals 0. Now this 2l square plus this 2ml plus this 2ml, 4ml plus 2m square plus Lm equals 0. That will be 2l into l plus 2m plus m into 2m plus l equals 0. So that gives 2m plus l into 2l plus m equals 0. So first we will write this 2m plus l equals 0 gives l equals minus 2m. We will use this value of l here, so we get n equals minus 4m plus 2m, that is minus 2m. So that gives this l equals minus 2m equals this n dividing by minus 2, l upon minus 2 equals m upon 1 equals n upon minus 2. So we get L, M, N equals minus 2, 1, minus 2. Next, from this 2L plus M, M equals minus 2L. Substituting this value here, we get N equals 2L minus 4L, that will be minus 2L, which is nothing but M equals minus 2L equals this N. Now from this 2L upon minus 1 equals m upon 1 equals n upon 1, dividing throughout by 2, that will be l upon minus half equals m upon 1 equals n upon 1. Multiplying throughout by minus half, we get l upon 1 equals m upon minus 2 equals n upon minus 2. So that gives us direction cosines of second line L, M, N equals 1, minus 2, minus 2. Now we have direction cosines of the first line minus 2, 1, minus 2, and that of the second line 1, minus 2, minus 2. Now angle theta between the two lines is cos theta equals mod of minus 2 I cap plus j cap minus 2 k cap dot I cap minus 2 j cap minus 2 k cap upon mod of minus 2 I cap plus j cap minus 2 k cap into mod of I cap minus 2 j cap minus 2 k cap. So that will be minus 2 multiplied by 1 minus 2, 1 multiplied by minus 2 minus 2, minus 2 multiplied by minus 2 plus 4 upon this denominator, which gives us cos theta equals 0, which implies theta equals cos inverse 0, that will be pi by 2 radians. So the correct option is A, pi by 2 radians. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. If set A equals a real number x such that mod x minus 2 is greater than 1, set B is a real number x such that square root of x square minus 3 is greater than 1, and set C is a real number x such that mod x minus 4 greater than or equal to 2, and Z is a set of all integers. We have to find number of subsets of the set A intersection B intersection C and complement of it. This is what we have to find out. We will find the elements of the sets A, B and C. So first, mod x minus 2 greater than 1 gives x minus 2 equals plus minus 1, that gives x equals 3 and 1. So which implies set A equals open interval minus infinity to 1 union open interval 3 to plus infinity. Next, square root of x square minus 3 greater than 1 squaring x square minus 3 greater than 1, that will be x square greater than 4, which means x greater than plus minus 2. So that gives p equals union of minus infinity to minus 2 to plus infinity. For set C, mod x minus 4 greater than or equal to 2 gives x minus 4 greater than or equal to plus minus 2, that will be x greater than or equal to 4 plus minus 2, so x will be greater than or equal to 6, or so set C will be from this greater than or equal to open interval minus infinity to close interval 2 union close interval 6 to open interval plus infinity. Now A intersection B intersection C will be the common to all these three sets, and those numbers will be this open interval minus infinity to minus 2 union this close interval 6 to open interval plus infinity. Therefore, this A intersection B intersection C complement of it will be A intersection B intersection C, and complement of it will be closed interval this minus 2 comma open interval this 6, and if this A intersection B intersection C complement of it is to be an integer, then this set will be minus 2 comma minus 1 0 1 2 3 4 and 5. Here number of elements n is 8. So therefore number of subsets of A intersection B intersection C complement of it will be equals 2 raised to n, that is 8, which is 256. This question was asked on 27 August 2021. So the correct answer is 256. If matrix A 0 to k minus 1 satisfies equation A into A cube plus 3 equals 2L, then we have to find the value of this k. This equation gives us A raised to 4 equals 2L minus 3A. We name it equation 1. Next, we will find A raised to 4 from this matrix. For that, we will make use of Cayley-Hamilton theorem. So first we will write the characteristic equation of A, which will be A minus lambda equals 0, which will be determinant 0 minus lambda to k minus 1 minus lambda equals 0. It gives lambda into 1 plus lambda minus 2k equals 0. That will be lambda square plus lambda minus 2k equals 0. Now according to Cayley-Hamilton theorem, every square matrix A satisfies its characteristic equation. Therefore, we can replace lambda by A and write A square plus A minus 2k equals 0. That gives us A square equals 2k minus A. Squaring this, we get A raised to 4 equals 4k squared plus A squared minus 2 times 2k into A. Here we will replace this A squared by 2k minus A and write A raised to 4 equals 4k squared plus 2k minus A minus 4k into A. That will be A raised to 4 equals 4k square plus 2k minus 1 plus 4k into A. We name this equation 2. Now we will compare equation 1 and equation 2 and find this 1 plus 4k equals 3. So 1 plus 4k equals 3, 4k equals to k equals half. So this will be the value of k. In the next question, we are given a matrix of greatest integer function of x, x plus 1, x plus 2, x plus 3, x plus 3, x plus 3, x plus 2, x plus 4. Here, this denotes the greatest integer less than or equal to x, and if determinant of matrix A equals 192, then we have to find the set of values of x lie between which given intervals. Now we use the strategy of converting greatest integer functions containing x plus 1, x plus 2, x plus 3, x plus 4, etc. in terms of only x. So for that, first we will simplify the given matrix A. We write the given matrix A as, for the first element we write greatest integer x plus 1, for this greatest integer x plus 2, for this greatest integer x plus 3. This will remain as it is, greatest integer function x. This will be greatest integer x plus 3. This greatest integer x plus 3. This will remain as it is. This will be greatest integer x plus 2, and this greatest integer x plus 4. And this we have written according to the definition of the greatest integer function, because we know that greatest integer x plus n is n plus greatest integer x, where n is an integer. We will simplify this matrix A by applying row transformations R1 minus R3 and R2 minus R3. That gives us matrix A equals, the first row will be R1 minus R3 will give matrix 1, 0, minus 1. R2 minus R3 will give 0, 1, minus 1. And third row will be as it is, greatest integer x plus 2, greatest integer x plus 4. This will give determinant of matrix A equals, this we will directly solve. So it will be greatest integer x plus 4 plus greatest integer x plus 2. That will be this one multiplied by greatest integer x plus 4 plus greatest integer x plus 2. Then this 0 multiplied by the next element will be 0, and this minus 1 multiplied by 0 minus greatest integer x. That gives greatest integer x, this one, and minus minus plus this one gives 3 times greatest integer x plus 4 plus 2 plus 6. Now this determinant of A, the value of which is given as 192. So we write 3 times greatest integer x plus 6 equals 192. This gives greatest integer x equals 62. According to the definition of greatest integer function, this means 62 less than or equal to x less than 63. Therefore, the set of values of x lie between the interval x belongs to closed interval 62, 63. The correct option here is B. In the next question, we are given the coordinates of three vertices of a triangle A, 0, B, 2b plus 1, and C, 0, B, where B not equal to 0 and mod B not equal to 1. And the area of this triangle is given as 1 square unit, and we have to find sum of all possible values of A. If these coordinates are x1, y1, x2, y2, and x3, y3 respectively, then we know that area of triangle ABC equals half times x1 plus x2 plus x3. Here in cyclic order 1, 2, 3, in cyclic order 2, 3, 1, in cyclic order y1 minus y2. Substituting the values, it will be A times 2b plus 1 minus b plus b times b minus 0 plus 0 times remaining bracket. It will be half times a into b plus 1 plus b squared. But this is given to be 1 square units. We write it plus minus 1. So that will be a into b plus 1 plus b square equals plus minus 2. So we get two values of a. The first will be 2 minus b square upon b plus 1, and the second value of a will be minus 2 minus b squared upon b plus 1. So these are the two possible values of a, sum of which will be this 2 cancels with this 2 minus 2b squared upon b plus 1. So the correct option is D. In the next question, it is given that mod lambda is the greatest integer less than or equal to lambda. That is greatest integer function. We have to find set of all values of lambda for which the system of linear equations x plus y plus z equals 4, 3x plus 2y plus 5z equals 3, and 9x plus 4y plus 28 plus mod lambda into z equals mod lambda. In the given system of equations, we have determinant of coefficients 1, 1, 1, 3, 2, 5, 9, 4, 28 plus mod lambda. That will be 2 times 28 plus mod lambda minus 20 minus 45 plus 12 minus 18. So that will be 56 plus 2 mod lambda minus 20 minus 84 minus 3 mod lambda plus 45 minus 6. So determinant D will be minus mod lambda plus 9. If this is not equal to 0, then this system of linear equations has unique solution. And if mod lambda plus 9 equals 0, then determinants d equals dx equals dy equals dz will be 0, and the system of equations will have infinite solutions, which implies lambda must be set of real numbers. So the correct option here is A. Next question is on permutations and combinations. It goes like this. A number is called palindrome if it reads the same backward as well as forwards. For example, a number 285582 is a 6-digit palindrome. We have to find number of 6-digit palindromes that are divisible by 55. Let the 6-digit palindrome be XYZ ZYX. Since this is to be divisible by 55, which means this digit in the units place must be 5, which follows this X also 5. Therefore, the palindrome 5YZZY5 is the required 6-digit palindrome. Now since 55 is divisible by 11, which means 5 plus z plus y minus y plus z plus 5 is divisible by 11 according to the divisibility test of 11. Now this is true for all values of y and z. Now 55 divided by 11 is 5, and there are 2 y's and 2 z's. Y can be chosen in 2 into 5, that is 10 different ways, and z also can be chosen in 10 different ways. Therefore, both y and z together can be chosen in 10 multiplied by 10, that is 100 different ways. Therefore, number of 6-digit palindromes divisible by 55 will be 100. So the answer here is 100. Next example is on binomial theorem. We are given that 3 raised to 6 upon 4 raised to 4 times k is a term independent of x in the binomial expansion of x upon 4 minus 12 upon x square raised to 12. and we have to find the value of k, this k. Now we know that in the binomial expansion of a plus b raised to n, the r plus 1th term is minus 1 raised to r into ncr into a raised to n minus r into b raised to r. Accordingly, we write expansion of this x upon 4 minus 12 upon x square raised to 12, and its t r plus 1th term will be minus 1 raised to r into 12 cr into x upon 4 raised to 12 minus r into 12 upon x square raised to r. So that will be minus 1 raised to r into 12 cr into this 12 raised to r upon this 4 raised to 12 minus r multiplied by the term in x, which is x raised to 12 minus r minus this 2r. Now for term independent of x, this power of x 12 minus 3r must be 0, which implies r equals 12 upon 3, that is 4. Therefore tr plus 1 will be t5 equals this minus 1 raised to 4 into this term 12 c4 into 12 raised to 4 upon 4 raised to 12 minus 4, that is 8. Here t5 is the term independent of x, which is given to be this term. So we write this equals 3 raised to 6 upon 4 raised to 4 into k. Therefore this k will be this 12c4 is 495 multiplied by 12 raised to 4 multiplied by 4 raised to 4 upon 4 raised to 8 multiplied by 3 raised to 6. That works out to be 55. So the value of this k here is 55. Next question is on binomial theorem. If the coefficients of x raised to 7 in x square plus 1 upon bx whole raised to 11 and coefficient of x raised to minus 7 in x minus 1 upon bx square, where b not equal to 0 are equal, then we have to find the value of b. First, let us find coefficient of x square in the binomial expansion of x square plus 1 upon bx whole raised to 11. First, we write the general term, which will be 11cr, this x square raised to r into this 1 upon bx raised to this 11 minus r. 11cr into x raised to 2r into bx raised to r minus 11. That will be 11cr into x raised to this 2r plus this r, x raised to 3r minus 11 into b raised to r minus 11. Since we have to find the coefficient of the term x raised to 7, which means that this 3r minus 11 will be 7, so r will be 18 upon 3, that is 6. Therefore coefficient of x raised to 7 will be 11 c6 into b raised to 6 minus 11 minus 5. We will name this equation 1. Next we find the coefficient of x raised to minus 7 in the expansion of x minus 1 upon bx square raised to 11. First we write the general term, which will be 11cr into this x raised to r into minus 1 upon bx square raised to 11 minus r. That will be 11cr into x raised to r minus 2 times 11 minus r into minus 1 upon b raised to 11 minus r. That will be 11cr into x raised to r plus 2r, that is 3r minus 22 into minus 1 upon b raised to 11 minus r. Since we have to find the coefficient of the term x raised to minus 7, it means that this 3r minus 22 will be minus 7. So we write 3r minus 22 is equal to minus 7. That gives r equals 15 upon 3, that is 5. So the coefficient of x raised to minus 7 will be 11c5 into minus b raised to r minus 11, that is 5 minus 11, that will be minus 6. So it will be minus 11c5 b raised to minus 6. We name this equation 2. Now since these coefficients are given to be equal, we write from 1 and 2 11c6 into b raised to minus 5 equals minus 11c5 into b raised to minus 6, which we write b raised to minus 5 into b raised to 6 equals minus 11c5 upon 11c6. That will be minus 11c5 will be 11 minus 5, that is 11c6 upon this 11c6, which will be minus 1. So the correct option here is B, minus 1. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.